This video is to continue to help you with problems on CR29. Now, really, the best case scenario, you're trying them on your own, then you're double checking against me. However, if you're just following through step by step, I do ask that you actually work through the problem with me and don't just copy from me. It's not going to get you anywhere. All right. Which table of values represents a linear function? Well, you know as soon as you see linear function, it can be in the form y equals mx plus b. That just means it's going to be y equals some number times x plus another number to get you to the other side. So let's just, and again, I happen to first pick the one that I'm pretty sure is linear. I can't believe my eye went there. Let me try to find one that's not linear first. So if you look here, you have to say, like, how do you get from 4 to 16? Oh, I can get from 4 to 16 by multiplying by 4. 4 times 4 is 16. How do you get from 9 to 81? Oh, 9 times 9 is 81. How do you get from 1 to 1? Oh, 1 times 1 is 1. How do you get from 0 to 0? Oh, 0 times 0 is 0. So if your x value is 0, you multiply it by itself. If your x value is 1, you multiply it by itself, 1. If your x value is 4, you multiply it by itself, 4. If your x value is 9, you multiply it by itself to get to your y value. So you, in this example, you take each x value, multiply it by itself, and that'll give you y. So that first table is y equals x times x. Hey, what's x to the first times x to the first? That's y equals x to the second. So you just square each of these numbers and get to the second value. All right, so the reason this is not linear is because of that exponent of 2. You can't have a squared attached to the x. This is a parabola. This is nonlinear. So it's not that one. Okay, let's see. Now I'll go to the one that it actually is, and that's where my eye went right now. How do you get from 0 to 0? Okay, that one's tough to see. How can you get from 1 to 2? Well, you might say I could add 1, so then you go to 4. If I add 1 to 4, do I get 8? Nope, okay. If I add 1 to 9, do I get 18? No. All right, let's look again. What's another way to get from 1 to 2? If I don't want to have to add 1, oh, I could do 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. Hey, it looks like each x is just multiplied by 2 to get the y. 0 times 2 is 0. So this would be x times 2 is y. So x times 2 equals y. How could I rewrite that? A lot of times I put my coefficient in front of the x. So that could be rewritten as 2x equals y. Or y equals 2x. Any of the above would be acceptable answers. So if I look here, do I have some number times x plus another number? You're like, I don't know. It doesn't seem to have a b. Oh, that b must be 0. It's in the form y equals some number times x plus another number. Definitely fits that form. That means it's linear. So this one's linear. These, there must not be a connection you can find going across. Because here, how do you get from 1 to 2? Well, I could multiply by 2, but 4 times, nope, that didn't get me there. How do I get from 9 to 6? No, those aren't working out for me. We could also on a grid plot these points to see why, but I'm not going to go any further because I've just shown you that it definitely is letter C. All right. Oh, is this your last problem? Maybe. Wow. All right. Number 6, triangle ABC undergoes a sequence of transformations resulting in triangle A prime, B prime, C prime. Describe a sequence of transformations to triangle ABC that would result in A prime, B prime, C prime. Okay, so we're looking at ABC and we know we got to get it down to here. Well, it almost looks like we're swinging this down 90 degrees and then doing something to it. So I might try, and this is how I handle these sequence of transformations. I truly don't know if I'm right, but it almost looks like A needs to get swung down, C needs to get swung down, B needs to get swung down. So I'm going to guess, this is literally a guess. I'm going to guess 90 degrees counterclockwise about the origin. That's literally a guess. Rotation, because it looks like A, B, C. So I'm going to get another transformation after that because we want a sequence. But it looks to me like if I take this and I swing it 90 degrees counterclockwise about the origin, that I'll be able to find a triangle down here that then I can shift into place. So I don't know, I'm just going to try it. I might not be right. So 90 degrees counterclockwise about the origin. Center of rotation is the origin. X, Y. We know first reverse. So it would become YX. Arrow, change the sign. So counterclockwise would go this way. So that's the one we're going to change. So I'm going to take each of my original coordinates. I'm going to first reverse, arrow, change the sign. And then we're going to see where we could get an image after a 90-degree rotation counterclockwise. Let's take a look. So the original coordinates of A were -3, 4. So now I'm going to do another A. I'm going to call it A, bump, bump, right now, double prime, just for right now. First reverse, 4, -3. Arrow, change the sign. Counterclockwise means I change that. So A, I'm going to call it double prime now, for now, would be -4, -1, 2, 3. So that would be like A double prime, only because A prime's already taken up. So let's look at the original B. The original B was -3, 0, -3, 0. So if we get our B, I'm going to call it double prime. First reverse, counterclockwise, arrow, change the sign. Changing the sign of 0, it doesn't affect 0. Like changing zeros, even if you try to change the sign, it's still 0. So now we have to go 0, -1, -2, -3. All right, we're going to call that B double prime. And now for our original C was -1, 3. I'm guessing it was a 90-degree counterclockwise rotation, so I'm going to say C double prime. First reverse, arrow, change the sign. So I'm going to change that sign, so it's -3, -1, and I'm going to call that C double prime. Then I have this beautiful triangle here. Ooh, it's almost sliding right into place. Then I say, now I actually have to land here. What could I do after my 90 degrees counterclockwise rotation about the origin? Oh, if I just took C and C prime, double prime, and translated it 2 to the right, I'd land here. If I took A and translate it 2 to the right, I'd land here. If I took this B double prime, translate it 2 to the right, I'd land here. So my second transformation in my sequence could be a translation 2 units to the right. And that's going to land you right where you need to land. Okay, describe a sequence of transformations that will result. Okay, so you can write it out better than I can, but step 1, a rotation 90 degrees counterclockwise about the origin, followed by a translation 2 units to the right. And if you know the original angle B was 30 degrees, the original angle B right here was 30 degrees. You know if you have a sequence of rigid motions, your new triangle, your image, is exactly congruent to the original. So if the original was 30 degrees, guess what your new angle has to be for angle B? That better still be 30 degrees. Rotations and translations, rigid motions, all angles remain the same, all side lengths remain the same. So what's the measure of angle B? Measure of angle B prime equals 30 degrees. All right, let's hope that's actually the rest of your problems. I'm going to double check. If not, I'll make a video for the rest of them, but I don't know. All right, hopefully that helps. Take care.